Welcome to The Explainer. Today, we're building an architect's playbook for a scenario that, well, it should probably keep you up at night. Kubernetes disaster recovery. And we're not just talking about simple backups here. We're talking about real, genuine, cross-cloud resilience. Okay, let's just dive right in with the question that every platform architect dreads. Imagine this. A whole cloud region goes down. Poof. Gone. Your dashboards are just a sea of red alerts. In that moment, do you have a plan? Or do you just have hope? The difference between those two is exactly what we're going to explore today. So, to answer that question with confidence, we're going to walk through a 6-part playbook. First, we'll break down what backup even means in a Kubernetes world. Then, we'll look at the tools you need, run through a full failover scenario, face some of those really tough challenges, and then talk about how to operationalize the whole thing. And finally, we'll cover the common pitfalls you absolutely want to avoid.
All right, first things first. When we talk about backing up Kubernetes, it is not, I repeat, not a single operation. It's really a multi-layered strategy. And, understanding these layers is the foundation for everything else we're going to talk about. It all starts right here with the cluster state. Just think of this as the architectural blueprint for your entire application. It's how everything is deployed, how it's exposed to the network, how it's all structured. This is the declarative what of your system. Next up, and you could argue this is the most critical part, is the application state. See, this isn't the blueprint anymore. This is the actual lifeblood of your service. It's the user data, the transaction records, all that irreplaceable information that's tucked away in your persistent volumes and databases.
And then you've got the configuration layer. This is all the vital stuff, the settings, the API keys, the database credentials, all stored in your config maps and secrets. Without this layer, your application blueprint has absolutely no idea how to connect to anything. It's just lost.
And finally, there's the platform metadata. This is what defines the whole operational environment. Who can do what resources they're allowed to use, and how the cluster is logically carved up. It's basically the rulebook that governs your entire deployment. So now that we know what to back up, let's move over to our toolkit, because knowing what you need to protect is only half the battle, right? The other half is choosing the right tools for each one of those layers we just talked about. Now, what's really, really interesting here is the core distinction between these two approaches. On one hand, you have tools like Velero. They're Kubernetes aware. They understand what a deployment is, what a service is. On the other hand, you have cloud-native snapshots. They're storage aware. They can copy disk blocks at incredible speeds, but they have zero clue about the Kubernetes objects that are actually using them. So, and this is the crucial point. This is not an either-or decision. Not at all. The professional playbook uses both. You use Velero as the orchestrator, sort of the brains of the operation, to back up all of the Kubernetes objects, and then you configure it to trigger those super fast, super reliable cloud-native snapshots to do the heavy lifting of protecting the actual data. Okay, enough theory. Let's get our hands dirty and put this into practice with a real-world example. Imagine, a regional outage has just taken your AWS EKS cluster completely offline. The business needs you back online, like yesterday. The plan? We're going to fail over to Google Cloud. So here's how it plays out. Step 1, you confirm your backups are actually there and accessible. Then you spin up a brand new, clean cluster over in GCP. Next, Velero does its magic and restores the Kubernetes objects. That's our blueprint. After that, you restore the actual data from your snapshots into new persistent volumes. And finally, you validate everything and cut over your DNS. The order here is absolutely critical. Of course, that failover scenario, it sounds pretty clean on a slide, doesn't it? But in reality, moving between different clouds introduces a ton of friction. A truly successful recovery means you've planned for all these complexities long before you ever need to hit the big red button. And this, right here, this illustrates the real-world gotchas. Your AWS storage classes, they don't exist in GCP. Your IAM roles, they need to be carefully mapped to GCP service accounts. And your load balancer configurations, yeah, they're completely different. Each one of these is a potential landmine that has to be addressed in your runbook. Which brings us to a really vital point. Having a plan sitting on a wiki page somewhere is, well, it's not enough. You have to operationalize it. You have to turn that theoretical document into a reliable, tested, and repeatable process, like a fire drill for your infrastructure. This checklist is your guide. It's all about setting clear policies, actively monitoring your backups for failures, and most importantly, conducting regular restore tests. Because trust me, a real disaster is the absolute worst time to find out your recovery process doesn't actually work.
All right, finally, let's learn from the mistakes of others. There are a handful of really common assumptions and pitfalls that can completely undermine an otherwise well-intentioned backup strategy. Let's make sure we avoid them.
These are the classic blunders. Believing Kubernetes magically handles state for you, or, backing up the YAML from your Git repo, but completely forgetting about the production database. And then there's the biggest one of all, setting up backups once and then never, ever trying to restore them. Just recognizing these traps is the first step to building a system that's truly resilient.
I'll leave you with this final thought, and it really sums up everything we've talked about. Your recovery plan is pure theory until you test it. So the question to ask yourself isn't, do we have backups? It's, what are we doing this week to turn our assumptions into guarantees?